My name is Alexander Berger. I'm site reliability engineer at Nexxiot, a track trace IoT company located in Zürich, Switzerland. So basically, we are AWS native shop mostly, so all our systems run on top of public cloud from AWS, multi-region, so because we have customers in different regions, some in the US, some in Europe. And if we look at what we are using from AWS, then it's mostly the infrastructure as service part, because AWS has a lot of services to offer, but we are very fond of the low-layered infrastructure part, which is very reliable and very performant, and we are very happy with that. So we're speaking about EC2, so the whole virtual machine thing, the whole network virtualization, the VPCs, and the EKS Kubernetes clusters that we basically use to build our own operating platform on top. And we use Pulumi to actually provision this low layer, as we say, of our operating platform. There's quite a diverse set of workloads that we in the end run on top. We have a lot of backend workloads that are just number crunching and data processing or serving APIs. These are usually, or all of them are run as Kubernetes pods on our Kubernetes platform. They are usually programmed in Kotlin or TypeScript, depends a little bit who wrote them, whether it's more a backend-centric team or more front-end-centric team that owns them. Infrastructure as code at Nexot has actually quite a long history. So when I joined the company back in 2017, we were using Ansible. And as you can imagine, Ansible is not really infrastructure as code, it's more kind of a configuration management system. We were not happy with that because actually we were going cloud native back then. So we tried out quite some tools that were available, and we ended up using Terraform. But we are not happy with Terraform. Terraform is purely declarative, as you might know, and we had a lot of needs to be more imperative because we had a lot of already existing infrastructure that we somehow needed to address and integrate into these programs. But we also had challenges with state management. So we started to supplement Terraform with a lot of extra stuff like Jinja templating and Python code that actually generated Terraform. We soon realized that's not sustainable and very complex. And we also missed help of compilers of type checking that would prevent us from doing mistakes when programming infrastructure. So we looked for better approaches back in 2018. We ended up evaluating AWS Cloud Development Kit, CDK back then. It was brand new. It was still going through a lot of changes, but we already got a good feeling this is the right direction. So it's imperative infrastructure as code where we can program quite flexible things. But still, we run into a lot of problems because AWS CDK is backed by AWS CloudFormation. And AWS CloudFormation has a few very important drawbacks. One of them is it's very slow, but we could have ignored it and just said, okay, let's go and have a coffee while stacks are applied. But the showstopper for us actually was that in AWS CloudFormation, the state of your stacks it's basically not under your control. You cannot easily export, modify, and import a broken state. Yeah? If a stack is in a broken state, you usually have to delete it. Yeah? And having to delete stacks is actually not what we want. We always want to have a way forward, to be able to fix a stack and to bring it to life again. Imagine if you have a database system owned by a CloudFormation stack and you have to delete the stack. You cannot afford to delete the database, you have data inside. You cannot afford the downtime this would cause, but you can also not afford the data loss that this would cause. So this kind of challenges. This is where we actually, more or less by accident, stumbled over Pulumi when it was still very young and fresh on the market. But we immediately realized, it has actually all the advantages of CDK, so it's imperative. It supports TypeScript, which is a strongly typed language, so we can basically profit from type checking of a compiler. And it also makes configuration management quite easy because actually TypeScript is very easygoing when it goes down to having interfaces which are just your configuration, but strongly typed. And basically also a little bit based on its inheritance from Terraform concepts, the state is actually something that you can extract into a JSON file where you can manually edit it and fix it and then import again and work on. So it solved this showstopper that we had with CloudFormation. I mean, the major pain point with Ansible is it's not infrastructure. It's a totally wrong tool for this job, yeah. It's very painful to actually create infrastructure. Of course, Ansible or hardcore fans will say, no problem, you can do that, but it's not intended for that, yeah. So if you have to spin up VMs, if you have to spin up something in cloud infrastructure on AWS, Azure, or Google Cloud, you name it, that's not what it's good at. Yeah. It's good at creating an SSH connection into existing hosts and then apply package manager calls or whatever. Okay, fair enough, but that's it. But that's not what we do. We do cloud native. We use immutable infrastructure. We don't update operating system content. We don't use package managers on the infrastructure. We spin up VMs. We point them at predefined OS images, which are basically immutable. If we need to upgrade, we have automatic process that keep them out, that take them out of work every 30 days or whatever, and replace them with newer ones, with the latest OS version and things like that. So we're not doing this classical IT patching that we did in the 90s or the 80s, yeah, which actually is where Ansible comes in. So we have no need for Ansible. We need a better tool. In Terraform, the biggest limitation is really that it's declarative. Yeah? Whenever you need a loop, whenever you have something pre-existing and you want to apply something for each item that already exists, no matter whether this what already exists is also managed by Terraform or has been created by another system, it becomes very tricky. You can do it, but you often run into limitations, yeah, and it's very, very complex usually. Yeah. That's certainly the most important problem we had. So we started to develop all this extra tooling around that actually generated Terraform, but did all this looping and lookup of already existing resources or whatever outside, but it was not sustainable. Yeah, it was just complex. We had to, in the end, maintain 3 things: Terraform know-how, Python know-how, templating, Jinja 2 framework was it, know-how, and we didn't like it. And also we are not a Python shop, yeah, so we didn't like having to use Python and Jinja because no type safety, no compiler that tells us if something is wrong. And we really don't like to run stacks that after half an hour just tell you, oh, sorry, there's a null pointer exception over there. Yeah, after waiting 30 minutes. That's not what we do. Not just because we don't want to face the risk of infrastructure being broken, also because we want to make sure we make optimal use of our precious time. So the biggest challenge there was really this unextractable state. Yeah. The state that is hidden somewhere in CloudFormation and you cannot influence it. Yeah. And we had this situation several times that CloudFormation told us, look, your state is in a broken condition and you cannot move on. You cannot just reapply the fixed CloudFormation stack. No, you have to delete it. And this is still the case today. This is actually quite ironic. We are not a key player in safety space or in finance or whatever. So the world is still going. Even if we are not available for 15 minutes, that actually would be fine. The way we do business today, IoT, collecting data from the field, this is all near real time, but not real time. And nobody dies just because our services would not be available. Economically, that's the situation. But the expectation from customer when they buy cloud services like ours is that it must be up 99.99% So they have very stringent requirements no matter whether it's relevant or not. So if you want to survive in the SaaS cloud business, you have just to be able to provide those numbers. Actually, adopting Pulumi was straightforward. I still remember the first day where I stumbled over the website. I saw some examples here, download the CLI program, install it, run it. It was quite straightforward, actually, especially with a background in CDK. It was quite obvious how to use it. It turned out actually that the real big challenge, especially if you then think about day 2 operations, which is the situation where you have existing systems that you cannot just tear down and that you have to continue with without interruption of service. Then the big challenges actually are state management and configuration management. So state management in the sense of, for example, with CloudFormation, although it has a lot of disadvantages, as we already elaborated on, but with CloudFormation, it's quite easy. You never have to care about the state. It's automatically dealt with by CloudFormation. They store it somewhere for you and it's fine. You never have to point it to the right place. Where is my state? Yeah. And with Pulumi, it is quite different. Similar to with Terraform, you have to tell it, yeah, where is actually the state stored? Yeah. Is it a local on a file? Is it in an S3 bucket? Or is it in the proprietary backend of Pulumi itself, the cloud backend? So you have to make this kind of choices. Yeah. How do I actually envision, or how do I need to store my state? Yeah. So before you can go for production setup, you must make these decisions. You're not locked in. You can still export and migrate to another place later, but this is an additional hurdle that you have to take. Yeah. And the other one is configuration management. Because with Pulumi, the way that Pulumi suggests how to do configuration management with these Pulumi YAML files in your top-level directory, that's nice. That works for small projects, but in the end, for big projects as we have, it's not optimal. Yeah. Because what we then had to develop is actually, we started to use the Pulumi automatization API. So we're not CLI. I mean, we're using the CLI, of course, but it's more in ad hoc fashion. But our Pulumi stacks are using the automatization API. And the configuration is actually a bunch of TypeScript libraries. So the configuration is not in YAML files or in JSON files or you name it. It's, again, TypeScript code. And this is a very nice properties that we actually can share configuration across different stacks, across different environments. It's a program, yeah? So it's very flexible. You can import parts, you can import functions, you can import types, you can reuse them, which makes it very, very powerful. This capability that we basically can write our own, let's say, driver, so the main function, yeah? And don't have to use scripting, yeah, to call Pulumi, but somehow inject configuration from our own system or credentials, yeah. For example, AWS credentials or things like that. And being able to write all this in one program makes it quite easy because we can all leverage TypeScript or whatever. I mean, we could also have written it in Golang or whatever, but we choose TypeScript, which is very powerful. We never have to leave this, let's say, zone of knowledge that we have about programming, yeah, and revert to scripting and YAML files or whatever. We can all do in the same technology. In this case, TypeScript, yeah. Makes it rather easy to maintain. I mean, easy. It's still complex, yeah, to admit, but makes it easier than if we had to combine 10 different technologies. As you exceed the limits of a single headcount team and you become a real team with multiple headcounts, your state file can no longer just reside on your local disk. And having it in a single place in the cloud so that each of your team member is on duty at that day can actually change it, that's important. And hand in hand with this, of course, goes the access control. So you have it in a shared place, but you have full control who can access this state. So which of my team members actually are entitled to deploy to this environment or change it. I think these are the key benefits. And of course, you get all the nice features of having a UI to inspect the state, which resources are in there, what is the change that gets applied, the visual representation of the diff of a preview. Of course, this also works on the command line, but it's always nicer to have it in a pretty UI. Yeah. So we take what we have and we slowly migrate it towards what we want to have, making sure that there is no interruption of service so that all the systems are up and running all the time while we actually replace fundamental pieces of whatever. Same applies if we just change something on infrastructure, but it also applies if we change tooling like we did for Pulumi. So it's an incremental approach. And to be honest, we still have CDK code around and we still have to migrate this to Pulumi as well one day. But this is, of course, often also a question of business priorities, because if you have something that works, yeah, why shall you touch it if you have better opportunities? Yeah. Usually, impact have things that don't work, yeah. Then you realize, oh, it's not working. And there's a lot of escalation going on. Everybody's aware it's not working. In fact, since we started using Pulumi, we never had any kind of outage caused by infrastructure management. So this is the positive impact. It works. It gets the job done, and we never had an outage. And nobody realizes because there's no problem, yeah. So it's a good thing. So you have to explicitly mention it, yeah. Here we are basically comparing license fees or usage costs that we pay with Pulumi Cloud versus human resource costs. Yeah? Because as soon as you have to maintain your own solution, like templating or whatever, then you have someone on your payroll. What a lot of people often forget about. They just compare their subscription fees and they do not realize that they have half of a team just being busy with doing something, yeah, that they actually could avoid if they use the right tool. So in our case, things became much cheaper, yeah. Cheaper for us to pay the subscription fee than to have two people on the payroll who try to maintain and understand all the tooling that we would otherwise have built ourselves. Yeah, if I have to select one point, then I'm excited to see where the Pulumi Kubernetes operator actually is heading towards. Yeah. This could be very, very interesting for us. If it evolves in the right direction, this could be a big value, added value for us. So I will recommend using Pulumi for everybody who starts on a greenfield approach with infrastructure as code, because I'm quite sure and confident to be able to say that it is the most powerful and versatile tool out there. You will run into limits with Terraform. You will run into limits with CDK, mostly because it's based on CloudFormation. Your biggest chances to not run into troubles and limitations is to use Pulumi. As with every project, in IT or not, keep it simple. Make clear design decisions up front. Everything you don't have to maintain. Everything you don't have to pay for. So try to do it, not perfect, but right, coming up with proper tools and designs. Yeah, that's the most important thing in IT, because complexity is actually what causes most costs in IT. Having a tool like Pulumi helps you to keep things easy. Yeah. Take your time, because as with everything new, if you do not understand it, you will start to use it like the other tools that you know. And if you use Pulumi like you use Terraform or Ansible, you might end up with unnecessary complex programs, yeah, which then again, you pay for, yeah. So take your time, try to understand the Zen and the concepts of Pulumi before you go all in. I'm quite sure and confident to be able to say that it is the most powerful and versatile tool out there.